Welcome to this Class 10 icse Mathematics lesson on Introduction to Trigonometry. In this video, we will understand the three basic trigonometric ratios, sine, cosine, and tangent, and solve three examples for each ratio. By the end, you should be able to identify the correct sides, choose the correct ratio, and calculate an unknown length or angle with confidence. The word trigonometry means the study of relationships between the angles and sides of triangles. At this level, we mainly work with right-angled triangles, which contain one angle of 90 degrees. Trigonometry is useful whenever a direct measurement is difficult. For example, it can help estimate the height of a building from its shadow, the distance across a river, or the angle at which a ramp rises. Let us label a right-angled triangle. First, find the 90-degree angle. The side opposite the 90-degree angle is always the hypotenuse. It is also the longest side. Now, choose the angle theta that we are studying. The side directly opposite theta is called the perpendicular. The remaining side that touches theta, apart from the hypotenuse, is called the base or the adjacent side. A very important point is that the names perpendicular and base depend on the chosen angle theta. The hypotenuse does not change, but the opposite and adjacent sides can change when the reference angle changes. For any acute angle theta in a right-angled triangle, the three basic ratios are defined as follows. Sine of theta equals perpendicular divided by hypotenuse. Cosine of theta equals base divided by hypotenuse. Tangent of theta equals perpendicular divided by base. A popular memory aid is SOHCAHTOA. SOHCA means sine is opposite over hypotenuse. Cosine means cosine is adjacent or base over hypotenuse. TOA means tangent is opposite over adjacent or base. Remember that these are ratios of lengths. So when the angle is fixed, they compare the sides in a consistent way. Before writing a formula, follow 4 steps. First, mark the given angle. Second, identify the hypotenuse. Third, identify which sides are given and which side is unknown. Finally, choose the ratio containing exactly those sides. If the perpendicular and hypotenuse are involved, use sine. If the base and hypotenuse are involved, use cosine. If the perpendicular and base are involved, use tangent. Let us practice each category carefully.
Sine examples. Example 1. In a right-angled triangle, theta is 30 degrees and the hypotenuse is 12 centimeters. Find the perpendicular. We know the angle and the hypotenuse, and we need the perpendicular. Therefore, sine is the correct ratio. Sine 30 degrees equals perpendicular divided by 12. Since sine 30 degrees equals 1/2 equals perpendicular divided by 12. Multiplying by 12 gives perpendicular equals 6 centimeters. Answer 6 centimeters. Full stop. Example 2. In a right-angled triangle, the perpendicular is 8 centimeters and the hypotenuse is 16 centimeters. Find theta. Use sine because perpendicular and hypotenuse are given. Sine theta equals 8 divided by 16, which is 1/2. Therefore, theta equals sine inverse of 1/2. From the standard angle table, sine 30 degrees is 1/2. Answer, theta equals 30 degrees. On a calculator, use the inverse sign or sine to the power -1 function, making sure the calculator is in degree mode. Full stop. Example 3. A ladder 10 meters long leans against a wall and makes an angle of 53 degrees with the ground. Find the vertical height reached on the wall, correct to 2 decimal places. The ladder is the hypotenuse. The height is opposite the 53 degree angle, so use sine. Sine 53 degrees equals height divided by 10. Therefore, height equals 10 multiplied by sine 53 degrees. Using a calculator in degree mode, height is approximately 7.99 meters. Answer, approximately 7.99 meters. Always check whether the answer is sensible. The height must be less than the ladder length, and 7.99 meters is indeed less than 10 meters. Full stop. Cosine examples. Example 1. In a right-angled triangle, theta is 60 degrees and the hypotenuse is 14 centimeters. Find the base. The base is adjacent to theta and the hypotenuse is known. Therefore, use cosine. Cosine 60 degrees equals base divided by 14. Since cosine 60 degrees equals 1/2, 1/2 equals base divided by 14. Thus, base equals 7 centimeters. Answer, 7 centimeters. Full stop.
Example 2. The base of a right-angled triangle is 6 centimeters and the hypotenuse is 12 centimeters. Find theta. Cosine theta equals base divided by hypotenuse, so cosine theta equals 6 divided by 12 or 1 half. Therefore, theta equals cosine inverse of 1 half. From the standard angle values, theta equals 60 degrees. Answer: theta equals 60 degrees. Notice how the same fraction can correspond to different ratios and different angles. 1 half is sine 30 degrees, but it is cosine 60 degrees. The ratio name matters. Full stop. Example 3. A 20-meter support cable makes an angle of 37 degrees with the ground. Find the horizontal distance from the foot of the support to the anchor point, correct to 2 decimal places. The cable is the hypotenuse. The horizontal distance is adjacent to the angle. Therefore, use cosine. Cosine 37 degrees equals distance divided by 20. Hence, distance equals 20 multiplied by cosine 37 degrees. The result is approximately 15.97 meters. Answer: approximately 15.97 meters. Again, the adjacent distance is less than the hypotenuse, so the answer passes a quick reasonableness check.
In a right-angled triangle, theta is 45 degrees and the base is 9 centimeters. Find the perpendicular. The perpendicular and base are involved, so use tangent. Tangent 45 degrees equals perpendicular divided by 9. Since tangent 45 degrees equals 1, perpendicular divided by 9 equals 1. Therefore, the perpendicular is 9 centimeters. Answer: 9 centimeters. This agrees with the fact that a right triangle containing a 45-degree acute angle has its two shorter sides equal. Example 2. The perpendicular of a right-angled triangle is 5 centimeters and the base is 5√3 centimeters. Find theta. Use tangent because the perpendicular and base are given. Tangent theta equals 5 divided by 5√3, which simplifies to 1 divided by √3. The standard value of tangent 30 degrees is 1 divided by √3. Therefore, theta equals 30 degrees. Example 3. From a point on level ground, the angle of elevation of the top of a tree is 40 degrees. If the point is 18 meters from the foot of the tree, find the height of the tree, correct to 2 decimal places. The angle of elevation is the angle measured upward from the horizontal line of sight. The tree height is the opposite side and the ground distance is the adjacent side. So use tangent. Tangent 40 degrees equals height divided by 18. Therefore, height equals 18 multiplied by tangent 40 degrees. The height is approximately 15.10 meters. Answer: approximately 15.10 meters. In real applications, remember to state the unit and round only at the final step unless the question tells you otherwise. Here are 3 standard angles worth remembering. For 30 degrees, sine is 1 half, cosine is √3 divided by 2 and tangent is 1 divided by √3. For 45 degrees, sine and cosine are 1 divided by √2 and tangent is 1. For 60 degrees, sine is √3 divided by 2, cosine is 1 half and tangent is √3. Now use the memory aid, sohka toa. Ask yourself, do I need opposite and hypotenuse, adjacent and hypotenuse, or opposite and adjacent? Let us review common mistakes. Do not call the longest side the base just because it is drawn at the bottom. The longest side opposite the right angle is the hypotenuse. Do not identify opposite and adjacent before marking the reference angle. Do not forget degree mode on your calculator. Keep exact values such as √3 when possible and round decimal answers only at the end. Finally, include the correct unit for a length and the degree symbol for an angle. Today we learned that trigonometry connects the sides and angles of a right angle triangle. Sine is perpendicular over hypotenuse, cosine is base over hypotenuse, tangent is perpendicular over base. We also solved 3 examples using sine, 3 using cosine and 3 using tangent. The most reliable method is simple. Mark the angle, label the sides, select the ratio, substitute carefully and check whether the result makes sense. If this lesson helped you understand trigonometry, please like this video, subscribe to the channel and turn on notifications for more class 10 icse mathematics lessons. Write one topic you would like us to explain next. Keep practicing and remember, clear diagrams make trigonometry much easier. See you in the next lesson.